Right. So, as far as our Guidewire engineering itself is concerned, we have discussed about understanding the integration part, including migration part, right? So that part we have already discussed in the previous sessions. Now, as far as our Guidewire engineering is concerned, today we are going to discuss about a multi-cluster management using Kubernetes, especially for any kind of policy-driven applications, all that. In that regard, so when we try to understand about the importance of multi-cluster, especially in the field of insurance, first of all, we must be knowing about uh, the importance of data and as well as data sovereignty, right? So because this is something essentially important, wherein which normally it's called as a legal requirement. Uh, whatever the regulations uh, requires the kind of data that we need to stay within the specific geographical boundaries, all that. So, enforcing strict data residency rules, along with implementing any kind of environment by implementing any workload replacements, uh, which is a strategic part, of course. So, which is a strategic part that we need to be updated by considering the industry globalizations. So, when we are implementing this from the Guidewire perspective, which builds a platform to operate across boundaries to ensure any kind of compliances in every jurisdiction. The reason of implementing this is to identify an operational challenges first, right? So normally operational challenges as far as the migrations or integration migration projects are concerned, maybe non-functional stuff, right? So it can be scalability, complexity, compliance, load balancing, all that stuff. So to manage global cluster footprints for a better operational efficiency in order to decrease against to the decreasing of operational complexity and all, we need to manage a number of clusters across region, so creating a new wave of operational challenges for infrastructure and as well as application workloads. So managing the clusters as individuals, handcrafted systems and all becomes unsustainable, so that we need to aim to embrace a new model, clusters and as well as standardizing replaceable units, which can be managed at scale. So it's always important for us to build the systems which must assign workloads to pool of clusters, so that whenever we are meeting the defined requirements, either it can be region, it can be binding them to a single cluster. So we need to automatically match all these workloads to the best fit clusters and all, continuously remap them as conditions change. In process of understanding this, normally there are multiple stacks that we are including in this, because the first one about OCM, let me write it here. The first one about OCM, we call it as. First one is about OCM. The second one is called Kubevela. Third one about crossplane. Next one about GitOps. So these are the four different stacks that we normally use. Right? So one is about OCM, which is called Open Cluster Management, which majorly an open source project serves as the control panel for managing any Kubernetes clusters at scale. Kubevela is a modern application delivery platform based on the OAM, which is used to describe and manage application workloads and the requirements, all that. When it comes to the cross-plane, which is an open source infrastructure as a code, which majorly extends Kubernetes with cloud native infrastructure management. Last but not least, when it comes to the GitOps, is to manage infrastructure and application updates by syncing the environments directly from Git-based configuration files, all that. But when trying to understand about this OCM component, interactions to deploy applications across clusters, how this can be implemented and how this looks like. So that part we are going to discuss in the next session.